Our next presenter is Andrew Lukianchuk. And the presentation topic is fracture criterion for tested PCM samples under strain.
Your presentation.
Show the presentation. So let's welcome the speaker, please.
Hello, everybody. My name is Andrew Lukianchuk, and I'm one of researchers of Central Hydrodynamic Institute in Russia, which briefly calls SAGI. First of all, I wish to acknowledge organizers of this conference and, of course, our project partner, Irkut Corporation. Today I'm talking about fracture criterion for tested carbon fiber reinforced polymers specimens under tension. Let's see on fracture criterion in practical terms and its application in industry. I divide my presentation into a few parts. First of all, I give you some background information. Then I'll talk about investigation of the moment of the beginning of the delamination using a wire sensor. And then I talk about debugging of growth sensor and development of the criteria. And at the least, I'll briefly talk about results of fatigue tensile test, which we can obtain by using this proposed file criterion. It's not a secret that to develop the theory experimental methodology for estimating of fatigue life of specimens or structure, it's necessary to obtain experimentally SN curves. And in our study, we used standard open holes specimens from CFRP. It was laminated, and for metal specimens, fracture specimen into two parts is used as a fracture criterion, and in case of zero to tension loading, it's okay, it's works well. But when we do the same thing with our specimens, it's laminated. We start to obtain an interesting thing, which you can see here. It is delaminations. Here it is. Delaminations was obtained visually at 19 degrees layers, and this leads to a large scatter of fatigue life. The root mean square deviation of logarithm of fatigue life, which characterizing the scatter, ranged from 0.7 to 0.9. Of course, such data is inappropriate, unacceptable to make some estimation of fatigue life, especially in aircraft structures. That's why development of new fracture criteria, the task of development of the new criteria arised, and this criteria must making it possible to reduce this scatter. In particular, it was necessary to solve a number of tasks for registration. Here it is, but the most important, it is what moment is considered to discussion, what moment is considered as destruction of the specimen. Let's move to another chapter, investigation of the moment of the beginning of delamination using a wire sensor. It is simplest solution, that's why it was chosen for the start of the beginning to investigation on this problem. And in this picture you can see broken wire sensor on specimen under tensile. When delamination on its edge reach its actual opening of about 0.1 millimeter, wire sensor broke, and machine was stopped, and the specimen was under ultrasonic non-destructive testings. And we start to obtain specimens which are what was not broken but have numerous damages, and the ultrasonic diagnostic shows us these delaminations areas, and it's very interesting, very important, but obviously usage of this wire sensor does not give a vision of moment and place of the beginning of the delamination, and therefore more precise and detailed control methods are required. In some literature we find the same picture, and some of them listed here, and one of them shows us this beautiful picture. Let's see, it is dynamics of damage development in an open hole specimen according to X-ray data. It is one before fatigue test, second in the time of fatigue test, it is at the end of fatigue test. It's really the same picture as we obtained. But this information, of course, will have a very limited application, because such non-destructive testing methods are not suitable for continuous monitoring of the state of a specimen. And in addition, such kinds of monitoring will increase the economic and time costs for conducted experiments. This will call into question of possibility of carrying out numerous multi-cycling tests on fatigue life, which are extremely important in the certification of aviation construction. Normative documentation and aviation rule says that delamination should not appear in the aviation construction, and that's why we for the fatigue test under tension, propose the criterion for the destruction of the specimen of CFRP can be considered to the moment of the beginning of the delamination in the zone of concentrator. I should say that inspiration of developing such methods was methods of estimation fatigue life of specimens based on degradation of its stiffness. Such methods are often used in estimation of fatigue life in wind turbine blades. Thus, a method of detecting of the initiation of delamination in the zone of hole is necessary, which must have following key features: continuous measurement, indication of measurement parameters in real time, and providing precise information about the onset of delamination. Let's move to another chapter: debugging of the sensor and development of the criteria. On this picture, you can see a specimen mounted on the test machine with a delamination sensor in the zone of the hole. The work of this delamination sensor was based on continuous fixing of thickness of specimen around the hole. And for this sensor, different thresholds were set from 0.05 to 0.5 millimeters. And when these thresholds were reached, specimens were mounted from these machines, and ultrasonic non-destructive tested was carriers on it. And this picture shows typical graphs of the dependence of the accelerometer readings from the fatigue runtime. I should say that these graphs are typical and similar from one specimen to another. And analyzing these two massives of data obtained by NDT method and readings from this sensor leads us to a quantitative criterion value. It is 0.05 millimeter, and I should say in this case dispersion of fatigue life not exceeding 0.3, which is acceptable for modern CFRPs. In this picture you can see illustration that after reaching the thickening of 0.05 millimeters, the areas of delaminations near the hole is similar. I should note that after reaching thickening of 0.05 millimeters, all investigated specimens were subjected to further tests with a gradual increase of the thickening threshold to 0.075 and 0.1 millimeters. But only 9 specimens reached a thickening of 0.075, and I should say that area of delaminations became comparable with the area of working space of specimens, and it was working as a 3 detached specimens. It was sliced. And move to the results, which can obtain results of fatigue tensile test, which can obtain with using proposed failure criterion. I should say, first of all, that experimental data for the construction of the SN curves was approximated by standard power law in this form, where C and M is experimental constants, which can obtain from a graph, and N and sigma fatigue and maximum stress of regular loading. Here it is data obtained. It was a special separate experiment, and whereas the point is experiment and the line is SN curve, it was a regular loading. The stress ratio, of course, was 0 to tension, and the delamination in this case was occurred in range of 1,000 to 1 million cycles. The level of loading was choosing that kind to get into this range. And of course, I should note that complete destruction was not achieved. It was used only this failure criteria. And in this case, fatigue scattering parameter was 0.21. It's a very good value of this parameter. It doesn't lead to unreasonable increase in reliability factors for fatigue life, and it makes this investigation is really successful. And in conclusion, I should say that this criterion demonstrates an acceptable repeatability of physical picture of the initiation of macro destruction, while the fatigue scatter parameter did not exceed 0.3. And such value of fatigue scatter parameter is acceptable for estimating the fatigue life, even in aircraft construction. And finally, I should say that the use of new materials in industry requires a revision of established criteria for destruction due to their unique new characteristics. And the main core of this report is of interest to researchers in this direction. Thank you.
Thank you very much. It is now open for questions. Yes, please.
I'm not sure if it's your slide 9 or slide 8. That slide, yes, it's 8. I'm not clear. Those dots, which are taken from experiments,
Yes, yes. This
occur, the specimen doesn't fail. So
yes.
how do you determine when to stop the test and when to say, I have so many cycles? What's your criterion?
It seems to me that my presentation is failed because I just talking about it because we take as a failure criterion the value of changing of thickness of specimen around the hole by this value.
At what change do you consider
This.
failure? When it's equal to a half a millimeter?
105 millimeter, yes.
And that you consider failure?
Yes.
Actually, if you have a structure with a hole in it, and you have this change of thickness, it can still carry load. So
Yes.
It's not really failure.
I should say that if you're absolutely correct, even when we obtain this, where the delimitation zone is comparable with all workspace of specimen, it carries load fully without any problem. But if we give him a little bit compress, it's immediately destructs. And in all of construction, we have how to say, we have end tension and compression. And if we obtain delaminations, we have a chance to catch this effect.
Thank you.
Thank you. Any more questions, please, for the speaker? If not, so let us thank the speaker.
Thank you.